Welcome to the video solution on worksheet number 7, which covered sections 4.1 through 4.3. We're talking about adding, subtracting polynomials, and then multiplying polynomials and dealing with some exponent stuff. So for numbers 1 through 2, we're going to add both horizontally and vertically. Note, use the commutative property to put like terms together for the horizontal process. Now some of these are simple and straightforward enough that you can just look if you understand what combining like terms means and actually do it, but we're going to show the process. So we're going to say negative 6y squared, and then we're going to use the commutative property to put like terms together before we add. That actually helps ensure that your answer is more correct. And then we're going to actually add the like terms together. That's y squared plus 3y. So that would be our answer. Now if we were doing it vertically, that means putting them in columns with like terms above like terms. And this is more of your traditional addition style method, right, where the numbers are on top of each other. So negative 6y squared plus 7y squared is y squared, and then y plus 2y is 3y. So notice you should get the same answer. You're still adding the same terms. So here we go again. Now this time's a little different because we've got some x squareds, x cubes, but they're not the leading terms as they were in problem number 1. So I'm just going to start with leading terms. And here's one way to avoid getting confused. My leading term is x cubed. The highest exponent is your leading term. So I put my 5x cubed, and I'm going to check it so I know that I've continued it and I've brought it down. Now I erase that because I don't know that it looks like a 5 anymore. So what's my next term? Well, here's a 10x squared. So I'm going to check that. And now I'm looking for just x's. I've got a 7x, and I've got a minus 8x. So I brought those, and I've got a minus 7 and a plus 3. And now I've assured that I brought everything down. It's in order, like terms are together, the x's are together, using the commutative property of addition. And then I put my constants together. So this equals 5x cubed plus 10x squared minus x, because positive 7x minus 8x is a negative x. And then I have a minus 4. Now we can check that that's correct by just doing it vertically as well. But again, we're going to take each term and put it in leading term order. There's no x squared, so I'm actually going to put a 0x squared just for the purpose of having an x squared column. And now I have a plus 7x and a minus 7. And I brought all of those down with me. Now I'm going to put the 10x squared in the appropriate column, the negative 8x in the appropriate column, and then the positive 3 in the appropriate column. So now I'm adding all of these. So 5x cubed plus nothing is 5x cubed. 0x squared plus 10x squared is plus 10x squared. Plus 7x plus a negative 8x is minus x, or plus negative x, whichever you want. And then negative 7 plus 3 is minus 4. Notice we get the same answer whichever way we do it. So on a quiz or exam, I might not ask you to use both methods, but now you have a way of checking it that's different than the first way you did it. So you can leave a quiz or exam knowing you've done it correctly by doing it both methods. And that's what's great about your level of algebra, is that you can have multiple ways of doing a lot of these things. Maybe not everything, but a lot of things. Now subtraction is trickier, and you want to be careful. Some students will want to distribute this negative sign through, which their intuition is kind of correct, but then they leave nothing there. So if you want to think adding the opposite, you can sort of change it to adding the opposite of 2y squared is negative 2y squared, and the opposite of positive 9xy is negative 9xy. Now you have an addition problem, so you can change this to an addition problem. And that's what I would suggest you do, because I think it's easier that way. So I'm going to take my leading terms, so y squared, and this is a negative 2y right here, squared, sorry. And then I've got a negative 12x, or minus 12xy. And then I've got this plus negative 9xy. And so we have y squared plus a negative 2y squared. That's just y squared, or negative y squared. And then I have minus 12xy plus a minus, or plus a negative 9xy. It's negative 21xy. Now my concern about you just kind of distributing it without looking at it is that some students will turn subtraction into multiplication. they'll say that this equals y squared minus 12xy. And then they don't know what to do after they distributed the negative sign, so they just do nothing. They leave nothing there. And then they make it look like this. But notice, this is now multiplication. So be careful when you're dealing with subtraction that you don't just all of a sudden turn it into multiplication accidentally. So now we'll do the column method. So we'll do y squared minus 12xy. That's our first line. And we're subtracting everything in the next term. 2y squared plus 9xy. The difficulty about this process is if you have 5 terms, and for each and every term you have to go back to this subtraction symbol, and we tend to forget it as we continue to go with the additional terms. Y squared minus 2y squared is our negative y squared. Negative 12xy minus the positive 9xy is negative 21xy. So now this matches this. And now we're going to look at this problem, and this problem is kind of jumbled out of order. It's actually an increase in exponent order instead of decreasing, and there's lots of subtractions happening. So we're going to do our little trick with adding the opposite of everything inside. And notice we actually end up with some nice positives happening once we've added the opposite of everything inside. So now I'm going to start with my leading exponent. And I'm looking to see if any of those are here. We have a positive 3y squared, but no more y cubed, so we're going to move on to that positive 3y squared. So I brought that. So I'm looking for y's. I have a minus y here. I have a plus 9y here. And then I have my minus 1, and I have a minus 9. So this time I've brought down things with their signs in place. Now we can combine like terms. We get 6y squared plus 8y minus 10. Okay, so we'll try the other method. 3y cubed plus 0y squared minus y and minus 1. And you're asking why is there 0y squared there? Because I have a 0y squared or some type of y squared over here, I need a column to put it in. So we want to make sure that we leave columns when necessary. And now we're going to subtract 9 minus 9y and minus 3y squared. And there's no y cubed here, so it's just 3y cubed. But now we have to say 0y squared minus a negative 3y squared is plus 3y squared. And now we're in the third column here with the y's. Minus y minus a negative 9y is the same thing as minus y plus 9y. Minus 1 minus a positive 9 is minus 1 minus 9, which is minus 10. And I think now I see I found an error. So by doing this 2 different methods, I found an error. So these are not like terms, so I can't combine them. And some of you may have caught that, which is brilliant of you. It's awesome if you can catch teacher errors. Not that you're sitting there saying, ah, ha, 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 she made an error. So now I have my answer that matches this. But yes, I make errors. Everybody makes errors. Teachers with 30, 40, 50 years of experience make errors. Why? Because we're human. It's okay. It's a matter of catching them. So what polynomial must be added to this? So we're struggling with how to set this up. So I've demonstrated previously how to do this. So just say what polynomial. I don't know what it is, but I know it's something. Polynomial must be added. You should know what that means, added. Must be added is the same thing as add. Then I have this negative 4x cubed minus plus 3x minus 8 equals, so that the sum is x squared minus x minus 1. So I give you a hint. Think of it this way. What number must be added to? And when we have an unknown in algebra, we use an x, right? What number x must be added to 5 so that this sum is 11, and that's why I typed here. And then we use our properties, the addition property of equations, to subtract 5 from both sides, and we get x equals 6. Only here we have a polynomial, so we don't want to call it y or l or p, because that could confuse us. You can if you want, but don't use x, because x's already exist here. So if you want to use y, that's fine, but don't just leave it at y equals something, because the question doesn't ask what does y equal. The question asks what's the polynomial, right? So I just put what polynomial in a box. That's my variable. So this is my variable to solve for. So how did I solve this? I subtracted, and so now I have to subtract this term from both sides, the entire term. Notice I'm not changing the insides of the signs. I don't know why I just underlined that, but I did, because my pen got too close to the tablet. I'm subtracting everything, keeping the same signs, so that this becomes a zero pair. And I've used that term repeatedly to try to enforce that this is a zero pair. So now we're going to subtract the same exact thing from this side. So here we are. So we have, you have to imagine there's 0x cubed here, because we have an x cubed here, but no x cubed in the column. And this is why I said it's kind of important to have your things in columns, because now we have a problem where we didn't know ahead of time that we were going to need columns, so we sort of have to manufacture it along the way. So 0x cubed minus a negative 4x cubed, or do I have an x cubed on that side? No, I don't. So it's positive 4x cubed. And then I have an x squared here, but I'm subtracting out 0x squareds because there aren't any here. So that's a positive x squared. Then I have a negative x minus 3x, which is minus 4x. And then a negative 1 minus a negative 8 is the same thing as negative 1 plus 8, which is plus 7. So we're saying that this is what the polynomial equals. I'm just going to say what poly. So how can we check this? Well, how can we check that our answer was right? We plug it back in, right? We're going to plug 6 in for x, and we're going to see if we get a true equation. I don't have a lot of room left to write here. So basically, I'm going to add our answer. Here, our answer was 6. Here, our answer is a polynomial. And I'm going to add it to this polynomial, whereas we added 6 to 5 here. So 4x cubed plus x squared, and this is our check, minus 4x plus 7. And then we're adding this to negative 4x cubed plus 3x, well, it's plus 0x squared here. And then plus 3x. Remember, I wanted to put a 0x squared, so I know that there was nothing there. That's all the reason I did it for. Minus 8. So these zero out, so there's 0x cubed, so I'm not going to bother to write at this point in time. I have an x squared minus 0, which is just an x squared. A negative 4x minus 3x is negative 7x. Oh, and see, I know I've done a problem already. I've made a boo-boo somewhere. Ah, I was pretending that I was subtracting. So I'm going to put an addition sign, because I confused myself. Negative 4x plus 3x is just negative x. And then 7 plus a negative 7 is negative 1. And notice that I'll put it in red. This is this. Sorry, I wrote over your x squared. So our check is done. So we're going to scroll down. Now we're multiplying. So we have to think about our rules. So we can just write some rules out. If I can get my pen going. Okay. So we have this x to the n times x to the m. They have the same base. So the base carries through, but the powers get multiplied. Sorry, added. I looked at this multiplication, and my brain didn't convert properly. So that's just the rule. So we're going to see how we apply that rule. Now I'm going to put terms together first. Or no, I'm not. I've decided not to do that step. So we have 8 to the 6th, but we also have an 8 to the 9th. So I'm going to go directly, instead of writing 8 to the 9th and then adding them, I'm just going to go directly to adding them. So this matches that, the base. So then I add those exponents. Now b doesn't have any other b's, so this just carries through. So then I get negative 7, a 15, b9. And these are those problems that you just can't check, except by going back through and doing it again. So now we're going to go over here. This time we only had the one coefficient of negative 7. Oh, that's what I lost. I lost the 4. I was wondering. I was focusing on the variables. There we go. Hopefully that's correct now. So now we have coefficients that are different, just like we had coefficients that are different here. I caught that though. So we have 8, because 2 times 4 is 8. Then we have a. And sometimes students get stuck because they say, well, the a doesn't have an exponent, but the a always have an exponent. The a always has an understood 1. Just like this also equals this, right? Previously in, I think, chapter 2, we learned that variables have the understood 1 in front of them, but we want to try to minimize how much we're writing, so we don't write 1 every single time. Most of the time we don't, once you realize that this equals that. So we also don't write a to the first, because again, we're trying to eliminate as much writing as possible. So it's just 8, and now we have an a, so it's 1 plus 3, because we're following the rule. This is a to the first times a to the 3. They have the same basis, so we add the exponents. Now we have b to the 8, and another b, so b is to the first power. So b to the 8 times b1, we add the powers. So now we actually add the powers, a to the 4, b to the 9. I want to encourage you to really take the time to understand how to use that one, because once we get to a different type of rule down here, it can start to become confusing. Okay, negative signs are negative signs. Don't confuse those with negative exponent signs. These are just the regular negative signs that you've been dealing with throughout the entire class and throughout all of your math history. So we have a negative times a negative, so our answer is positive. So we just go like that. We're done with dealing with the negative signs. So now we have x5 plus 8, y8 plus 9, and then we just have our z. There aren't any other z's to be combining with that. So this equals x13, y17, and z. So on an exam or a quiz, and if it says x to the 52, times x to the 308, all you're doing is chapter 1 stuff, really, because you're just going to add those exponents to get to the final answer. Okay, so I think I'm done there. So now we have 3 times negative 9 times 2. So there's one negative sign, so the answer is negative. So 3 times 9 is 27. 27 times 2 is 54. And for some reason, this comes up a lot. So we have a to the 5 plus 1. Right here is the plus 1. B to the 1 plus 1. And then we have a c to the 1 plus 5. So it's negative 54, a6, b2, c6. So remember, when it's just sitting by itself, it has an exponent of 1. When they're just sitting by themselves, they have the exponent of 1. So don't forget that, and don't treat it like 0, because it's not. So now we're going to go down to here, and now we have to have our other rule in place. So our other rule was x to the n, which is an exponent, raised to another power equals x to the n times m. Okay? So the first off, don't start combining things. This entire parenthetical term is being raised to the power of 3. So the first thing we're going to do is raise each part to the power of 3. A squared to the power of 3 and b to the power of 3. Okay, so I have my 3 right here, I have my a squared right here, and I have my b right here, and each of them is being raised to the power of 3. Now, some students then get confused. Well, there's a cube here, so I guess I'm supposed to take negative 2 to the cube. But the cube is attached to the a, so negative 2a cubed does not equal negative 2a cubed. Okay? They don't equal each other. This cube is being attached to this a. Okay? So now we're going to start clarifying, evaluating these exponents. So a squared raised to the power of 3 is a to the power of 2 times 3, because we're following this rule now. And then we have b to the 3. And now we're going to start multiplying our numbers. So it's negative 54. Now we have an a to the 3 times, because parentheses mean times, but I'm just going to put a dot here. But now what do we have? We have an a to the 6th, because we have 2 times 3 is 6. So you're using two different rules in this problem, and you have to know the difference between them. And now we have b3. And then this finally equals 3 plus 6, because now we're using the rule at the top. Notice this has one base. Don't start multiplying these because you have two terms. This is one term. Okay? So you have to use the other rule that has two terms. So that would be the final answer. And I know that sometimes our A's and our 9's get confusing. So just try to do your work in such a way that I can tell the difference between an A and a 9. Okay, so now we're multiplying. So that means it gets distributed. So negative 8y squared gets distributed to the y. And then minus 8y squared gets distributed to 2y squared. So combining these now by multiplication, we get negative 8y cubed minus 16 y to the 2 plus 2, y to the 2 plus 2, because we're following the rule at the top of the page, not this rule, is 4. So that would be it. Now, when we move on to chapter 5 and we do factoring, then you would be taking this and pulling out a greatest common factor to get back to here. Okay, so now we're going to multiply this through. So I feel like this problem was in our, this problem above and this problem were in a quiz video solution. So I'm not going to spell it out as clearly now as I did in the video solution. So I'm just going to tell you that I'm going to do this arrow thing that you guys are doing, but you guys aren't actually following through with all the arrows is the problem. So this goes here, this goes here, and this goes here. So we'll do that part. So negative a squared times 2a is negative 2a cubed. Negative 2a times positive 2a is negative 4a squared. 3 times 2a is plus 6a. Now we have to go this way. So negative a squared times negative 1 is positive a squared. Negative 2a times negative 1 is a positive 2a. And positive 3 times negative 1 is negative 3, or minus 3 anyway. So now I have actually followed through with all my arrows, not errors, but arrows. Notice the number of arrows corresponds to the number of terms you start out with. So there are 6 arrows, and so there are 6 terms. But now you're going to start combining them. There's only one cube term. There is a couple of a squared terms, and that's minus 3a squared. There's a couple of a terms, so it's plus 8a, and that's minus 3. So we're going to do the FOIL method that we discussed in video lecture, or the arrow as well. FOIL are the first ones. So 7a times 3 is 21a squared. Outer, 7a times 7 plus 49a. Inner, 3 times 3a is plus 9a. Last, 3 times 7 is 21, and then you combine like terms. So it's 21a squared plus 58a. If my arithmetic is correct, you will tell me if it's not. So again, we're going to do the same thing. Now, in chapter 5, you're going to take something that looks like this and magically make it look like this. 2x plus 8, 2x minus 8. So that's 4x squared minus 16x plus 16x minus 64. And notice that these are a zero pair. So we end up with 4x squared minus 64, and this is going to be called the difference of squares in chapter 5. So you're going to be given something that looks like this, and you're going to have to get back to here. Now this last problem of the worksheet I like a lot. So we're going to draw the picture. I always suggest, as soon as it says triangle or diamond or circle or half sphere, whatever you're supposed to do, draw it because it helps the visual. The rectangle, the width is 3x plus 2. That's what it's telling you. The length is twice the width. And what was the width? 3x plus 2. So what's the formula for area? Area equals length times width. So we're going to start substituting. Now our length, we're going to finish this distribution here. 6x plus 4. 6x plus 4. And our width is 3x plus 2. And then you just multiply them through. So we have 18x squared plus 12x plus 12x. Oh, interesting. Plus 8. And let's make sure we did that. That's 16x squared. That is 12x. That is 12x. And that's plus 8. So we have 18x squared plus 24x plus 8. But we're talking about area. Area of things have units. Centimeters, meters, feet, etc. And in fact, this one was inches. So area is inches squared. And we'll talk about that briefly. 3 squared can be written as 3 times 3. So inches times inches then can be written as inches squared. And why is it inches times inches? Because your length is inches, your width is inches, so you end up with inches times inches right in this line. So in the last line it should look like inches squared. So that's the end of the video solution for worksheet number, drum roll, number 7, which covers sections 4.4 and 4.3. We'll see you in the next video solution.